Good morning, everyone. This video is to teach you a little bit about a patterning and algebra concept called sequences. And sequences often deal with finding patterns in order and order in patterns. So some helpful definitions to get you started. If you're currently in one of my classes, you can find a definition table on the back of your unit overview sheet. The first term is sequence, which is a set of numbers arranged in a particular order, and they're normally related to a pattern. Most sequences studied by mathematicians follow a pattern. In some cases, patterns or sequences can be random, but some people argue that something being random is a pattern into itself. Your second definition is term, which is a piece or part of a sequence or pattern. Now, terms are often referred to as T1, T2, etc. You can have an infinite number of terms in any pattern if you know how to figure it out. So to start, think about the following number sets: 2, 4, 6, 8, 10, something you've probably seen before, and 100, 50, 25, and 12 and a half. When you look at those numbers, what are some commonalities or patterns with regards to these numbers? Take a minute to think about it. You can always pause the video. Think about what you see or what you don't see in those patterns. So in the first pattern of 2, 4, 6, 8, 10, the pattern is an increase of 2. So the first term, 2, is increased by 2 units to get the second term, which is 4. So 2 plus 2 is 4. The second term is increased by 2 units to get to the third term, so 4 plus 2 is 6, and so on. Another way to think of this is to think of the pattern in relation to the first term. So to get the second term, you take the first term and add 2 once. To get the third term, you look at the first term and you add 2 twice. Okay, so there's 2 different ways of thinking about it. And if that kind of trips you up, come see me and we'll do a few more examples. But those are really the 2 main ways of looking at sequences and ways of finding patterns that we're going to look at for this video. So in the second example of 100, 50, 25, 12 and a half, sequence decreases by a factor of a half. So you can either multiply the previous term by a half, or you can divide the term by 2. Now, if you were to look at this sequence in terms of the first term, the alternative way, you're really going to get a smaller fraction that you multiply the first term by. So for the second term, you're multiplying the first term by a half. To get the third term, you're multiplying the first term by a quarter, and so on and so forth. So this is a little more of a trickier example. And if you're a little fuzzy on this, again, come see me and we can do a few more examples that play with fractions. So to kind of summarize the first little part, to determine the formula for any term in a sequence, often referred to as the nth term, I know that kind of looks weird, you need to find a pattern and use it to write an expression or equation for each term number as a function of its term number. Okay? So it's okay to be confused after that. It does sound a little bit wordy. Just file it away for now and remember I said that. Okay? You can always rewind the video and review it once you think you kind of understand it. So here's an example. Our first term is 5, our second term is 7, our third term is 9, and our fourth term is 11. Our fifth term is 13. What is our pattern going to be? What's the difference between those terms? Take a minute and think about it. Maybe jot down your answer. Talk to a partner. All right, let's keep going. So the difference between the first and second term is plus 2. So to get the second term, you add 2 to the first term. You can see that this table is in relation to the previous term. Okay? So this is where we look at term 1 plus 2 is term 2. Term 2 plus 2 is 3. Okay? We're not looking at relation to the first term. So you take the previous term, add 2 to get your next term. So to draw it out here, if I take my pen Well, the pen doesn't seem to be working. But what you do is you add 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, 11 plus 2 is 13. Okay? So, if we were to look at the same pattern, but in relation to the first term, we get something a little different, but still very similar. So, the first term plus 2 gets you the second term. The first term plus 2 times 2 over here gives you the third term. The first term plus 3 times 2 gets you the fourth term. The first term plus 4 times 2 gets you the fifth term. So we're relating everything into in terms of the first term. Okay? So again, two different ways to look at it. I just jotted this out. It didn't format properly. So just kind of pretend this slide didn't happen. So if you're trying to determine the pattern rule formula from the previous pattern, okay, and I've kind of put it there below, try and think about how you could possibly find a formula for the pattern. So you might want to just reverse the video a little bit and look at the previous slide to get that table. When I imported it to this slide, it kind of got all weird out on me. Okay, so now that you maybe have an idea of the formula or the pattern rule, jot it down. Maybe show it to a friend, compare notes, pause the video, have a little chit chat. Okay, because the next slide is going to tell you the answer. So the formula for this sequence is Tn, which means any term can be found by doing 2 times the term number plus 3. Okay, so if we were to do n is 1, we're looking for the first term. We put in 2 times 1, which is 2, plus 3 is 5. So let's check our formula. If we're correct, then we should get 5 we put input 1 as our n value. So just like I said, Tn equals 2n plus 3. And you'll notice that I'm doing this in the way that I expect you to answer it. First line is the formula. T1 equals 2 times 1 plus 3. 2 plus 3 is 5. So therefore, term 1 is 5. So word of caution. When you think you have the formula, I recommend checking your formula with 3 values, 1, 3, and 5. If you input these and get the answer you expect, then your formula is likely correct. Just checking with 1 as your value sometimes doesn't work out in your favor, because what happens is 1 is such a simple value that that's the way you base your formula. So of course 1 is going to work. You need to put in some different values to make sure it works as well as you think it does. So now that you have the formula, what would your 32nd term be? So you input to get your output. So Tn equals 2n plus 3. We're looking for our 32nd term, so n is 32. So term 32 is equal to 2 times 32 plus 3. 64 plus 3 equals 67. So therefore, the 32nd term of this sequence is 67. Now what if I asked you to tell me what term the value 383 is? And there's the bell. So some of you are coming in pretty soon. So we're looking for the value that 383 is. So in the previous example, you were solving for term 32, or your output. Now you have the output, or the answer, and you're trying to determine what your input was. So let's take a look at this. So here's our formula. Our output is going to be on the left side of the equation. Our input is going to be on the right side. So last time we were solving for the left side of the equation using the right side. This time we're solving for the right side of the equation using the left side. Let's take a look. So our equation is going to start like this. 383 equals 2n plus 3. Remember, we're solving for n. So 383 minus 3 equals 2n. I just moved that positive 3 to the other side of the equal sign, so I reversed the sign. So it went from positive to negative. 383 minus 3 gives us 380 equals 2n. I divide both sides by 2 to isolate the n. So 380 divided by 2 is going to equal n. Therefore, n is 190. So our final statement, therefore, the value 383 was the 190th term. I hope this video helped. If you have any questions, please feel free to see me, or you can always watch the video again and pause it where you're a little confused. Thanks for watching.